we have heard a lot about IoT, I think, for the last 5 to 6 years ago. But to some people, they might just know about this quite recently. But however, I think a lot of us didn't realize that IoT can do a lot more than what they have imagined. So maybe I would like to share with you some of the slides first, and we'll go around. But I also like to encourage you to sit around until the end of the presentation, because I do have a contest and some prizes for you, some surprise. So, okay, hold on with that. Okay. If you just for a background check, is that a lot of people sometimes understand IoT is all about having sensors. But in fact, Internet of Things, by definition itself, is quite simple. If you know that IoT is not only sensors, but it comprises of 4 components of technology. The first one, as you know, is the sensors, which have been transformed from the analog form into digital sensors. I think with digital sensors, you can quantify that much easier as compared to human sensors, which is quite analog. You can only feel, you can only sense, see and all that, but you need to explain a little bit about, but you cannot even quantify about the temperature itself. So the digital sensors can tell you what kind of gases inside your room, how many percent it is, the actual location of your place in terms of latitude and latitude. And you can check whether the distance of the proximity, you can know whether you are within centimeters away or even 1 meter away. So sensors in digital form is a better way to quantify things. And of course, we need the second component, which is most likely we will use wireless, even though fixed network also is possible. Traditionally, we have been using technologies like for the local part, where it's quite near to you. You might have RFID, you might have NFC, but you can even have like Bluetooth or Wi-Fi as your local area network technology. This is where all the devices within a building can be connected without very expensive way of doing that through a gateway which have a Wi-Fi gateway or a Bluetooth gateway. So it's simple. From there, the gateway will send out to another network, which might be wide area network, which can be like 2G, 3G, 4G, and now recently the 5G. Yeah. But also we will see that new technologies of IoT have come out, which is very suitable to transmit data in a smaller format and a smaller form. And because of the low frequency, it can also send further away. And it also have the capability to provide you with a better battery consumption. So a lot of devices, which is on standalone, so you can be at the field. So it needs to have less battery consumption. So technologies like LoRa, the LP1 technologies, LoRa, Sigfox, and NB-IoT are one of the few technologies which can be used to transmit data. Yeah? So the third component is where you want to aggregate the data, you want to collect the sensors. And it's due because of the many kinds of sensors which have different protocols, different messaging formats. So you might need a better way to aggregate that on a platform. So this is what we call the middleware. So it will manage your devices. It also allows you to access the data through a set of API for you to acquire the data to make new applications. You can build an application surrounding the data that you have collected. So that's why you have seen about people are doing smart parking, smart vehicle tracking, smart health monitoring, smart monitoring of agriculture. So these are the applications which being built when they acquire the data. But of course, with that kind of data, it's not about applications that you can build, new workflow, but you can also use the data for learning purposes. Decision-making purpose. So with machine learning, for example, you can do prediction. Once you have learned the data, you can predict what happened next, or you can do some prescription technique. Yeah. So these some of the things that we need to know whenever we are going to deploy an IoT solutions. So for some people, it's no longer like you're buying one hardware, you can build anything, but this is quite complex in a sense for some people, because now they have to know a lot more than just purely hardware. They need to know the connectivity and the way that you program and manage the data, and maybe you want to write your applications. That's why a lot of things, people didn't realize that IoT can do a lot more things, because anything that can be connected to the internet can be very useful. But the question is how IoT can really impact us. Yeah. So most of the time, if you want to do and offer these solutions to your own business or the business of your customers, you just take a look at the 7M that it can transform the business. So any part of the whole organization can be transformed and can make it more better in a way. For example, the first M, we always talk about the manpower. The cost of the manpower is quite high, because you have to pay the salary and all that, and because it takes time for certain people to even do some meter reading. For example, you have to go to remote to get access and to measure things. What if you can do this via Internet of Things? You can monitor that from remote. You don't have to send people out again. So this is what makes us better in that sense. I did remember last year, what happened is that when MCO happened, there is no one is able to move around freely, and even the meter reader of our electricity bill, TMB, unable to send people out to get the reading of your electricity bill. So what happened after 3 months, you get suddenly a big bill. So people are questioning, how if you are unable to get human to make get the reading, might as well, I think it's better for you to get the reading through a technology like this. Yeah. So it can lower the manpower cost. You can also increase the productivity of their manpower. But this also give a lot of challenges where people are afraid that their job's going to be impacted. And then we take a look at the materials, the assets that's moving around from the ships to the logistics to your warehouse, for example. You will have to ensure that the materials are, just in time sort of thing, rather than you overstock or understock. So understanding the assets, the location, the whereabouts, the condition of the assets is very important. So with the right sensors, you can know and understand whether the assets are in very good condition in terms of temperature and humidity, or even you have a GPS, you know the location where it's going to. Yeah. So this is one, the second M. The third M, if you have machines, expensive machines that you are unable to monitor that regularly, or you didn't know when you want to do a proper service, or when exactly the machine is going to break down. So with this, IoT devices that being monitored across the whole machine, you will know only the uptime of the machines. So you can understand when you want to do a real predictive maintenance, rather you want to do a scheduled maintenance. So you can pick up any errors happening at the machine, and this can optimize your machine itself. So people who are in industries which have a lot of machines, this is something which is very beneficial for them, especially in the industry. And then we take a look at the methods. A lot of times there's a lot of processes ongoing, and as a human, you might intervene as the one that can sign off certain processes. I mean, when it reaches you in terms of paper-wise, you need to sign off. But in terms of technology-wise, then you can ensure that anything that being triggered can automatically being approved, for example, for certain decision-making process. So it's going to reduce a lot of this unnecessary workflow or process. So red tapes also is not going to be there. No longer people are in the middle in stopping a lot of data going to be transmitted. So because of digitalization, it's going to be much faster in terms of exchanging information. And then we take a look at the market. I think it's easier when it's all now in digital form. You can create your own, not only in local market, but you can expand this into global reach, yeah, better. And then you take a look at the money aspect, where people feel that the current business is insufficient because they need to be very competitive. So IoT is able for you, enable you to create new products. So this will be becoming your new revenue streams. But most likely with this new product comes with new business models. You can charge the customers differently. And of course, you can save other costs. And then you take a look at the seventh part is where the management would love to make a proper and accurate decision making. With only one source of information, or the source of information is quite late in receiving it, so you make the decision quite late. So with data that's being gathered from remote, you can have this data on real time. So in terms of decision making, it's going to be very faster, and more accurate because it comes with different sources of data. And of course, for you to ensure that you can also share this data with other management groups of people, group of management, you can make this transparent for them. And of course, that will, give you a better look about the whole organization health. Yeah. So one of the things is quite difficult for many people when I mentioned about these 4 components IoT. It seems that there's no single organization or any vendor who can provide the whole expertise of design and deliver and deploy the whole end-to-end solutions. Because reason being is that everyone have their own expertise. If you are in the hardware company, you might be good in developing hardware solutions. But if you are in telco, you might be the one that provide the connectivity alone. But of course, you might not be good in terms of the platform itself who can aggregate and host the data. Or you might need a group of people who can create the applications. So, of course, this requires what we call that ecosystem. Yeah. So, an IoT ecosystem, which I mentioned to you just now, the 4 main components, it is needed because if you can do a collaboration between all your partners, you can leverage their strengths and their resource, and you can make yourself different from the others. Unless you are, if you work alone, then you have difficulty to differentiate because your weakness is still there. But what if your weakness can be assisted by your partners? And then we look at the gaps in your product portfolio. You might feel that there are certain gaps which it's not complete. You have difficulty to go very fast to the market. So instead of having you alone going out to the market, you might work with the parties like, application developers or the right hardware vendors and to go to the market very fast. So you can reduce the cost of your capex or investment to build, to have your own R&D. And then, of course, with that kind of partnership, we also have the ability to access to having a better outreach to the market. Yeah, of course, with that your partner strength who have, for example, the one in other countries, they might be good in terms of their own market space, and they are good in the hardware, but you are the one that have the applications, can work with them and can access the market from the other side. So in that case, you can free up a lot of resources in terms of customer relationships. So, other people will help you in terms of making sure that you can go to the market. So if you look at the four main components just now, where exactly the money can comes from? Yeah. So if you are the device provider, you know that the money can come from the number of devices, the edge devices that you have created, the gateways, the system integration work that you can do. And the network providers, of course, they can charge according to their telco connectivity charges with, that kind of, bundle packages or coverage, a different technology that they can provide. And the platform providers, they can get the money from, sometimes they based on how many devices can you attach, connect to the platform, and how many APIs that you can use. The number of APIs mean the services that you consume on the platform. Yeah. So any new services that going to be supported by the platform. And the application provider, of course, as the software developer, they might not think so much about the rest, but they can create new dashboard, new analytics engine. They can do more advanced data services and big data analytics to their own customers. So if you want to reap the benefits of IoT, there are few things that you need to learn to build an IoT solutions. So this is where I would like to share with you that journey of building an IoT solutions. What are the necessary jigsaw puzzle that you need to put in place to ensure that, hey, I have enough things, enough knowledge that I can build an IoT solution. So one of the things, if you are in data communications or in the computer group of people, there is this 7 layers of open system interconnection that you need to understand. These are the maximum layers that people normally will explain whenever for a simple communication needs to take place. So for example, you have a content and you want to send this content to another place. This is how it works. So for example, in the application layer, the uppermost layer is the applications layer, is where you have your applications. So it can be a simple voice communication, but it can also, in this case, it's more on data communication, maybe through email. So you might have various protocols that can be used, like HTTP, FTP, SMTP for email and all that. So that is the 7 layer. Then it will translate your content and present it on a different manner. For example, you need to put some encryption technique, to make it secure. So you put SSL, SSH. You want to compress your data. Sometimes people talking about translation. So you have MPEG, JPEG, and all that. So that's on the 6th layer, which is presentation layer. Then on the session layer is where you do that session, starting your session communication. You need to start to communicate with the other part of your device. You start the communication process, because without the session, you cannot start to transmit your data. And then, of course, you will know whether you want to send through TCP. Is very it can control your any error. Otherwise, you want to send much faster, you can use UDP, for example. So that's the TCP part. And then it goes to the network part. So it gives you an IP address. And from there, it depends on which network they want to use, the data link. So in this case, data link can be in many forms. On the fixed network, it can be Ethernet. In wireless network, it can be like Zigbee. You can have like Wi-Fi. You can have Bluetooth. You can have NB-IoT. So these are the different protocols being used depending on the first layer, which is whether it's physical or wireless. So in this case, a physical, you might use a coax cable or fiber optics, or you might even use wireless. Then you must have some form of modulation technique. So that is the 5 layer, which is the physical layer. So which in different intermediate node, you might just have, from one node to another node, you just go to a network layer. So with an IP address, it doesn't have to go through the upper layer until it reaches to the other end. From device A to device B, it will retranslate back all the packets, the bits and the bytes into real information. So this is the 7 layers of OSI which we need to know. And then, of course, in IoT, they also define what they call also the 7 layers, but slightly in a different way. Of course, you can put these 7 layers almost the same as what I mentioned earlier. Not necessarily all the 7 layers. It can be reduced into 7, 6, or even 5. But of course, the below layer is where the thing is, the hardware, the sensors, the actuators. So you define that depending on what data that you want to collect. And then from there, you have the connectivity layer. This is where, as I mentioned to you just now, through Wi-Fi, through DCG, or even Alora or NB-IoT. And then you might have your cloud infrastructure who aggregate the data. And then data ingestion, you harvest all the data, and then you do some reporting, mining, and machine learning for data analysis part, and you can create the applications. By the end of the day, finally, there will be people who make that decision. You have a process flow which as mentioned to you can shorten the process flow, and you can create an application, you can make decision based on your applications. When we take a look at the connectivity part, I like to focus more on the technology like LP1, the low powered wireless area network. So with LP1 technologies, they have these two licensed spectrum, which mainly the telco is operating that. And then you have the unlicensed spectrum, which anybody can use the spectrum. So in the case like licensed spectrum, the most popular one is the NB-IoT and the LTE-M. So LTE-M is being evolved from the LTE infrastructure. NB-IoT from ground up, they have built this new network. So the 3GPP is building the standards for that. And then we have the unlicensed spectrum. This is mainly being done through organizations, private organizations, like Sigfox, for example. They have a Sigfox Alliance, and then they have LoRa Alliance, LoRa. So Sigfox in Malaysia is being operated by Esperanti. Like LoRa, you can do and build your own infrastructure. Like NB-IoT LTE-M is being rolled out by current operators like Celcom, Maxis, DG, or even TM Malaysia, Telecom Malaysia. Yeah. Other than that, there are unlicensed band, which is other comparative technologies, which is like Wi-Fi, Jupiter Mesh. This is something I don't want to focus, but this is some of the industry-based technology of connectivity. But when we look at LP1 itself, the most famous one, as mentioned to you just now, the LTE-M, NB-IoT, LoRa, and Sigfox. It depends on the kind of modulation technique they have built and how big the spectrum that they have been given to that particular technology. The higher the bigger the spectrum, the higher speed that you will obtain. But of course, with the issue of battery consumption. Yeah. So with different technologies, they have different in terms of coverage, battery consumption, application scenario. Yeah. So in the case like this 3GPP LP1 standards, people getting more and more confused of which one to choose. So sometimes I would rather use a table, and when we get the requirements from the user, then we have to choose the right technology and which operator in your country actually have that kind of technology. So it doesn't have that, you might choose the next best one. Yeah. And next best one in terms of cost and all that. So people look the LTE-M, for example. When they choose one LTE-M, they will see that it has higher throughput as compared to others. And it has lower latency and better mobility for you to move around. Certain devices need to be mobile and can roam to other countries. And then they want to see whether the power efficiency in terms of data rates and whether it can use any secure connections. So in the case like LTE-M, they is best suited for technologies like asset tracking, healthcare, wearables, retail, smart home security, and many others who have maybe higher data rates compared to other normal IoT solutions. Yeah. So if this is the case, you might use LTE-M. But if you want to use NB-IoT, it has a longer range. Yeah. But you also have better penetration within the buildings, but difficult in terms of terrain conditions because of the frequency. And then maybe you have that greater efficiency at low data rates, and more to some, it is better because it's cost effective in terms of data plans if there is an operator operating that case. So NB-IoT is best suited for like smart metering, smart agriculture, environmental monitoring, smart city, and many other applications which requires a better or good battery lifetime, low bandwidth utilization, and extended range. Yeah. So you might choose NB-IoT. But people are getting confused again, man. You see, you want to compare NB-IoT, LoRa, and Sigfox. How do you want to choose that? So normally we will have this table and understand where's the need. So if that's the requirements is, you have a good range and also good battery life and maybe cost efficiency, maybe that requires you to choose Sigfox, for example. But then in NB-IoT, you want to choose because of the quality of service or the scalability, the latency is much better. So you might choose that as your requirement. Yeah. So now once you have identified, the hardware sensors that you want to build or you want to create yourself, you want to choose the right connectivity as I mentioned to you previously, you might also need to have a platform to acquire the data, to read the data and manage the devices, which can be from 2 or 3 devices up to thousands of devices. So it depends on user requirements. If you have only very few devices to manage, do you require to build your own platform? Because that platform can be very expensive to maintain and even develop. But if you have many devices, you might also need to have that in your own premise. So it depends on your user requirement. Because this data can come in many forms, now 4V is because of big data. Some people call it 8V. So in this case, you can have a volume of data that comes to you need to handle data which is in small volume or big volume, and you need whether your platform can maintain multimedia, different forms of data from normal text to videos, for example, and then your platform need to handle data that comes in slowly and maybe data that comes in very fast manner. So, and there's data which is kind of veracity. So you need to do this for big data analytics. Yeah. So data alone that you have received below is just the normal numbers and symbols or the bits and the bytes, I would say. So that data, people might say this is a new currency. But of course, this new currency doesn't make meaning unless you can make something useful out of that. So it's like just like an oil, it's a black oil, and unless you can change the oil into something more useful. So meaning to say this data can translate or can answer the questions of who, what, where, and when. And that's really the information. That's the information that you want. But it can answer the questions of how, then it becomes purely knowledge. And then it can answer the question of why, then it becomes understanding. The higher it goes up, then you have that wisdom part where a human have that capability to do that, because with all the information, understanding, and knowledge below, they add up with what we call the empathy part, the emotion part, where human can make better decision-making process with that. Yeah. So for example, in smart parking, it depends. In indoor parking, you might have sensors like infrared that sends the light down and will detect whether there is a car beneath that parking lot. Or you might have another sensor outside which can detect the ferromagnetic sensor. It can detect the metal which is under your car. It can detect. So that's for external parking sensors. But whatever sensors, it doesn't matter. It will just tell you whether someone is parking on that particular parking lot or not. So with that, then you might ask yourself, it's much better if I know who parked at that particular lot. Now we don't know. Actually, we know only the car is coming in and they park it. And what kind of vehicle? We are not sure. And where is the parking lot which is empty? Maybe you need to know more about that. And when is the peak period where the car park is fully utilized? You might want to know that. Maybe not for the driver, but maybe for the parking operator. The higher it goes up, the parking operator wants to know more about how they can implement a tiered charging mechanism. When it's peak, I can charge it higher. When it's low, you can charge it off peak when you charge it lower. So people can be attracted. So you can have an automatic change of your parking. And then you need to understand the parking utilization. The parking operator wants to know why this month is only 10% utilization. Next month is 100%. Another month is 30%. You need to understand the trends in your parking lot. Yeah. So with that, as I mentioned to you, it can benefit the end users or it can benefit the parking operator. As the end user who drives, they would like to know where is the empty parking lot, yeah, the location of the parking availability. With an app, they can detect it easily, yeah. So as a parking operator, they want to know the parking utilization. So with a single sensor, it benefits two users, the drivers and also the parking operator. So then you can monetize them differently. Yeah, you can either have a new services for the, you can entice new users to come to your place, to parking in your area, and you can also help the parking operator to know better about their assets. So that's why I think like business intelligence have now grown into higher details, where not only the data that looks in terms of information and knowledge and getting the insights, but of course the final thing that you want to do is that you must have this action. So then you have that proper decision making. Okay, let me share with you what we have on the third component is that the platform itself. So one way that we also feel that to help the end users to build their own IT solution, it must be made easy. So rather than you have difficulty once you have the hardware, you might have a platform which is only meant for one particular hardware, but when you have another hardware, you have difficulty to connect the sensors into that hardware because the platform is not flexible enough and not open enough. So what if you can use any platform which is around, which is open enough for you to use? So let me tell you about the platform have different ways, different ways of hosting that. So in a traditional on-premises base, a middleware can sit inside organizations. So you manage everything from the networking part, storage, virtualization, the operating system, middleware, data and applications, you manage everything. So a lot of users feel that they have the right IT people and they want to manage and maintain the whole infrastructure. Then they can do that. But more and more now that we have a very thin number of IT group of people, so sometimes they outsource some parts of the infrastructure. So for example, they want to reduce the hardware portion because they want to maintain the hardware. So being managed by the vendor, the networking part and storage, servers and virtualization is being managed by the vendor. The rest, they still want to control them. So then we call this infrastructure as a service. In a platform as a service is where a lot of things have been managed by the vendor, but as a user, they control their data and they create their own application. And then finally, you have a software as a service where applications like you see now, like Google have launched a lot of software as a service. Yeah, Google Calendar, Google Email, everything is on, you just subscribe to that software. So you don't own anything. It's being owned by Google. So in our case, for example, like Favoriot, one of the players in IoT, we provide the infrastructure, the platform, and you can control your own data and applications. So when we talk about platforms, there are so many platforms around. That's where people get confused. And now, since last 2019, there are 620 platforms. And people get confused. So you can see a lot of players there. So reason being is that the growth started in 2015 in IoT. And people started to build. So you see a lot of startups, solutions providers entering the IoT market space. And they build this platform because they can't wait. Any IoT implementation must have a platform. So in order for you to do that, this will expedite the whole development process. And again, if you look the whole IoT ecosystem, there are many players, as I mentioned to you just now. So you need to understand the whole building blocks. If the building blocks can talk to each other, it's much better. So we don't want to tie up in one vendor specific. So not all vendor is able to provide end-to-end solutions. So you have to ensure that every piece of the puzzle can work together. So when we take a look at IoT platform, also there are four main categorization. So of course, the big ones, the Google, the Amazon, the IBM, these people are the public company, public traded company. So these companies manage a platform. They they are big players, but they enter in slightly quite late as compared to the rest because they see the market, then they will enter the market. And then we will see the end-to-end connectivity player. These players are the one already built hardware, and there'll be a solution on top of their hardware. So they have their own sensors, platform, and applications. The only issue is that they work very well, very closely and very tightly knit. But this platform, once you have that, you cannot open up for other devices to connect. You have difficulty to create new application because it's very close to their solutions. And then we have the open source. It's just a platform for open source. The community, the one that manage the open source, and you might use the open source, some of the licenses, and you can create your own platform. You can build on top of that. And then there are developer-friendly platforms. People like ourselves who open up the platform, which is very horizontal. We want people to create more and more vertical applications. So you manage your own data, but through your own sensors, and you can extract the data out and you can create your own applications. So as I mentioned to you, data and applications is being owned by the owner. So what the platform can do is that they manage devices very well. They allow remote connections from many devices. They can even manage the data with certain business rules. So certain temperature raise price to a certain limit, then they will send I would call that a trigger process. You can have enable analytics, visualizations. So this is a very key in terms of ensuring that you can easily manage your devices. So the factors that you want to select a certain platform is based on this platform is network agnostic. It can connect to all the networks that I mentioned to you earlier. Yeah, and then it's protocol agnostic. You can have core app, REST, MQTT, and it has the capability to manage devices well. It can scale globally, and it has end-to-end security and ensure that it can have easy of use for developer to create applications. So for example, like this, when we create Favoriot, we launch it, but suddenly we found out that in the early phase of our product development, we open up this product for other developers to create, but they don't have the right talents to put the pieces together. So now we are encouraging the end users and open it up. So we have a lot of information that people will come in and subscribe to the platform to create their own applications. So we teach them how to build IoT solutions. Yeah. So when we manage devices, we just look at very hierarchical manner. You have a project, a smart city project. Under smart city project, you can create many applications: smart parking, smart river monitoring, smart air quality, and all that. And then from there, a smart parking might have different groups. They're based on location based. And then you have devices attached to that particular location. And then you have data streams that attach to that particular device. So easily for you to extract the data out from one single application or one single group. So as I mentioned to you just now, the platform have many features. So as mentioned, you can have that real-time alerts for you to send through a Telegram, SMS, and also email. It has a graph board, we call it. The graph board means that once you have created a dashboard, you can make it public. Yeah? You can also have very real-time display of this data. So with that, we also have these platform users from around the country. So 80%, 75% is mainly from Malaysia. The rest is from other 108 countries. Yeah. So in terms of development-wise, you got to understand there are 4 stages of IoT development. One, you might have the skills in engineering. You might do the assembly of the physical hardware, the sensors, the boards. And then you must have the skills to program the sensors and what we call the connected device and send to the server. And then you must have the ability to program the server to receive the data and store it. And then you send it out, the data to display the data on the device user on the mobile phone or even on the computer. So these are the top programming language that you need to learn, from C to C++ for devices, Java, Python, and C++ for gateways. Cloud maybe Java or JavaScript. Yeah. So these are most valuable programming language that you can learn when you are building IoT. So the simplest way for you to start off is that you must have a sensors, you have the connectivity, and then you have the platform to manage it. So this is one of that we have built in Malaysia, the Hibiscus Sense, just like your Arduino board. And then from that board, you can turn that into an application, a real application for monitoring a tracker badge, monitoring social worker, retirement home, employee trip. You can do that. So applications to do SOS and so on and so forth. So a lot more applications can be built around that. So I would like to give you this contest. So prepare with your mobile phone. This contest will provide you with a 1-year beginner plan for free. It's worth 100 ringgit for 1 year. And then you can have a 30% discount, 2 vouchers. So I want you to do this. I give you about maybe 3 minutes for you to do this. Quickly log into this link, and then you scan it, you register as a free user with your valid email address. And then the first person starting now who registered will get that free Favoriot beginner account. And I will pick the number 10th and number 20th person who registered to get a 30% discount voucher of this beginner plan. So the winners later will be notified that via email. So please do this. I just give you just for 3 more minutes because we have another 10 more minutes for slightly question and answers. Yeah. So you must provide a valid email address for us to contact you back. If you put a wrong email address, then I'm sorry that we cannot give you the notification of your vouchers. Right. And also, if, for example, if you have registered, you can use another email address to register your second account. You can test it out while I'm looking at if someone of you can, put any question and answers here, and then okay, then most likely I will answer that. Okay. There will be a slides being given. I think I'm not sure the slides can be given during the end of my presentation, the link, and you will take a look at that. Yeah. So the beauty thing about this is that you can start it very easily, freely. Some users have started it using a video that we have created, and within 2 hours, that person is able to connect his board into and send the data out. So if they look at this simple step by step, it's easy for them to get the data out. Okay, I'll give you 1 more minute for you to register. I can see that there are quite a number already have started to register, and we will inform you later. The one that is a little bit slow in terms of registration, don't worry. The number 10 and the number 20th will also get a discount. Yeah. It's quite simple to do that. Okay. Due to the time, maybe I'll just continue again, right? So there are many other applications that you can build. Yeah. So for example, like us, we feel that we can build an application for smart environmental. So you have sensors that can collect water quality, weather, water monitoring for any leakage and water level for flooding case and all that. It becomes a smart environmental applications. And the best part is that you can also blend this data together. So you can have many data, even can predict, you have data from all the rivers that you can predict there is any floods that are going to happen or not. And then in smart city applications, for example, we have put this into a data center. They can even do number counting of parking, either sensors or maybe through a boom gate. They will detect whenever the car passing by. and then the noise and air pollution at certain public places. This is good for monitoring the smart city, and also for water treatment plant. They want to check whether there's odor monitoring and water being polluted at the riverside. Yeah. And then for industry purposes, they also have these applications to monitor the assets, the whereabouts of the assets, the conditions in the warehouse. And also power monitoring, monitor the power of the applications, where you can monitor whether the place have power or not. They will send alerts to the facility management and the smart factory. So with that, if you take a look at all of this, all this data and the partners that within you can harness that power and create new applications. And how do you want to start your IoT journey? It's quite simple. You start with developing a small and a very focused solution that have impact to your problem. Yeah. So it can give impact so that you can have a buy-in of your end user, your CEO levels. And then from there, you can integrate that with your back-end system or your existing system. And later you can connect it and more and scale it up. You can get data, and then you can have new workflow, new business model, more better analytics. So I think with that, if you have concerns or things that you would like to communicate with us, you can contact us, or you can have access to all this information through all my social media. So with that, I would like to pass again back to my moderator. Thank you. Amir.
Thank you. Thank you very much, Dr. Mazlan, for the presentation. I guess the presentation is quite heavily technical, but I think some of us managed to understand how to harness the power of IoT. Yeah, of course, I do have several questions here. When you mention about the application of IoT, especially the smart parking, I remember I had experience when I used this kind of parking service at quite a number of shopping malls where they offer parking lots that are located nearby the entrance or probably opposite the entrance. All I need to do is to so-called download the parking apps. I could actually book the parking slot that I wish to park my car before I even arrive at the shopping mall. Is that kind of example a kind of IoT application that is already happening in Malaysia?
Yes, they are. So they have allocated certain numbers of parking lots, and they know the availability of the parking lots whenever there's some sensors stating that there's empty parking lots. Once you have, so they will know when you have the app, you will know how many parking are still available. But that is in a controlled environment. It's not like the big parking lot where everyone is sharing. So exactly. that is already happening.
In fact, this kind of parking service is expanding its coverage not only in big cities like Kuala Lumpur, Selangor. I guess there are also the same parking services offered outside Selangor and Kuala Lumpur. Another question, when you mention about IoT platforms such as open sources, which is freely available for the users out there, maybe you can suggest some IoT platforms that are considered as open sources with our participants who may be interested in adopting IoT.
Okay, I have mentioned that in my slides. There are few that is being covered there. One of them is like, for example, the ThinkSpeak, Car, these are Zeta. So these are some of the open source. So in that slides, I've shown that. Yeah.
Okay, thank you very much. Do you think Alexa or Siri also perform, the same functions as IoT? For example, if I wish to say, Alexa, play some music, do you think that's kind of IoT application as well?
Yes, it is. As I mentioned to you just now, it must have the sensors, and then it must have the connectivity applications and platform, right? So the sensors is the voice. So it will detect your voice, recognize the command. It will trigger through its wireless connectivity to an application server which resides in Amazon, for example, in Google, for example. And then from there, it has an application to perform it. So if you look at that 4 components, it's quite easily for you to see that hey, this Alexa and Siri is actually an IoT applications. Waze, for example, is an IoT applications because it has sensors that detects your location of the car, and it sends the data out through its own wireless 3G or 4G. It has a Waze server that collects the data. Then they have the applications that can gather the data and give you the recommendation stating that the best route to take for this driving from this to your destination is this routes. So that is an applications that being built around IoT. Yeah.
Many of us have heard of IoT in the past, and in fact, many of us, including me, do not really realize that we are currently using IoT, probably because of the features, because of the internet. I thought these are just connected to the internet instead of connecting between devices. Just now, you also mentioned a lot of examples of IoT application in services such as, smart metering, smart parkings, and so on. For example, in chemical industry, if you see at the chemical plants, there are a lot of actuators, sensors being used to monitor the entire operation of a chemical plant. And how is this different with the IoT application? Can the same IoT application be embedded in the chemical plant operation?
Yes, there are sensors which is mainly standalone. So you might able to read the data when you already in that place. So it's not IoT because you didn't send the data out to the cloud, or for example. So if you have sensors which can detect the dangerous gases, right? Very, very dangerous cases, and you can immediately being informed, being triggered from remote, then it's going to be an IoT. So we see these applications where a consumer type of IoT, which we mentioned just now, like Waze, Alexa, and all that, we can see industrial IoT, which is the one that you mentioned that in the very industrial base. We see that IoT also can transform the way that our business model, like for example, now you're paying you're paying what like apa tu insurance, everyone be the same. Why should the insurance be the same? It should be different because my driving pattern and your driving pattern might be different. If you're a safe driver, my insurance should be lower. If you're a reckless driver, your insurance is going to be very premium, very high. So the way that they want to quantify your driving pattern is by putting sensors inside the car. Then it will tell you the way that you accelerate, you brake, you corner, and then it will tell you, oh, you are very reckless. You are 10%, below the threshold. Then you're being charged higher. Something like that.
That's very smart, Dr. Maslan. Yeah, I remember for heavy drivers like me, like most of the time I'm on the wheel, so I rely heavily on Waze. And yeah, I believe that Waze has recorded so much, especially when driving patterns. And for that reason, Waze could actually help the insurance companies, especially decide on how much insurance I should subscribe to. I have a lot more options, which insurance value I should buy, and so on. I think we have come to the end of the session, Dr. Maslan. Thank you so much, Dr. Maslan, for responding to the questions and the presentation too. We are grateful to have you in our today's webinar. Would you like to say a few words before I conclude our webinar session?
Yes, I think in IoT, there's a lot of things that you can do, except that it's just the power of your creativity and the way that you want to innovate things. It can solve a lot of problems. So we need to start now to get the volume up so that the cost can be lower. So that's the challenge in IoT because the cost is still higher because the volume is still small. But we are seeing at the tip of the iceberg, it will grow and become very exponential very soon.